essentially, we've seen big changes over the last few years in terms of security, but fundamentally, I think security's strength is that we've seen a lot of investment. There's lots of investment by customers. They've been putting lots of money into trying to defend against this disastrous threat landscape that's out there. And the response of the marketplace, certainly in terms of investments, certainly venture capitalists and so on, is they've sort of matched that apparent demand in the field with actual investment in products and so on. I think there's a big question about how successful that's been, in the sense that there's more and more money that's being spent, but it doesn't seem to be having a massive effect in the amount of money that's being lost from breaches and so on as well. But nevertheless, you would hope that if there was a market whole, that this is the sort of shape that you would see. You'd see demand from customers and response from the industry. And of course, you're also seeing responses as well in terms of the number of people who are being trained in this. But I'd argue that that strength is also the weakness of the traditional security market as well, because what does this result in? Well, it results in fundamentally this. So that's security today. So you have a fundamental model that says that we start out with these very expensive firewalls that everybody has put hundreds of millions of dollars in over the last few years. We'll keep that because we've spent a lot of money on it. But as we have all these new things like cloud computing, mobility, containers, virtual machines, all of those need a slight tweak to that traditional security model. So all of that money you saw earlier has resulted in lots and lots of brilliant people in Silicon Valley and elsewhere, all producing little tiny point solutions to try and match these little use cases that fit on, but still maintaining the firewall in the middle. Now you can imagine, I mean, we've got customers all over the world, in the City of London, in the US, who are now saying that the result of this is their portfolio of security tools is now over 100 products. Now each of those products has got their own APIs, it's got their own user interfaces, they're all completely different. So we've got to a point now where these might actually solve some security problems, theoretically, but actually they've actually given rise to a much bigger problem now, which is how the hell do you manage all of this? All of these are separate, all of them are different, and many of our customers are now saying that the problem of managing this is almost overtaking the security problems that they're meant to solve. So what can we do about it? Well, I just thought, as I was in the Netherlands, I thought I'd give an analogy which you should recognize. I mean, this is the modern security industry is a bit like the boy trying to plug the hole in the dike. He sees a leak, so he puts a finger in it, and then another leak picks up somewhere else, so he puts another finger into it. And he keeps on doing that until, unfortunately, he's run out of fingers. And that's sort of the parallel of where we are with the traditional modern security. The question is how do we stop patching the dike, and how do we actually fix the problem instead? Fundamentally, what that all says is the traditional security model augmented effectively to try and deal with all these new use cases just isn't fit for purpose any longer. And the reason it's not fit for purpose is that it's introduced a level of complexity that just isn't manageable any longer. So the exciting bit of this presentation is that we've decided that essentially you need a new model for security 2.0, if you like, and it can't revolve around the traditional model of let's surround the infrastructure or the network with a big perimeter firewall. I mean, for a start, where the hell is the perimeter anymore? It's very difficult to tell. So complexity is the enemy of security. How do we fix that? Well, some of the key challenges that raises are, first of all, we've now in a situation where it's not just about PCs or terminals sitting in an HQ building connected via a blue cable to a mainframe somewhere in the basement. We've got PCs, we've got Macs, we've got mobile devices, we've got we've got these things, the sort of things we're talking about here. none of which that original model was designed to essentially deal with. We've also got different application models. So we have cloud, we have multi-cloud, we have private cloud, we have stuff that's still resident in the data center. Different types of applications, SaaS, monolithic applications, modern applications that consist of sort of networked microservices. We have massive diversity, none of which was really encompassed by that original model. What does that mean is suddenly the attack surface for bad actors in terms of security breaches are concerned, there's now too many effectively for that traditional model to defend. Also, we still have this. I don't know if it's the case in your organization. We see this all the time. We have an IT department. We have a security department. We have a networking group. And it's amazing how much the data shows that they don't talk to each other, or they don't talk to each other very effectively. So the organization is siloed. The tools and the language that those people, those professions use, they're also different. So even the software designed to support all of this is siloed. And that just makes all of this complexity even harder to manage. And then finally, within that context, that area of complexity, the fact is we're not short of information that you could need to be able to make your infrastructure secure. But what you are is short of how all of that information interfaces together, because they're all using different terms, different languages. There's no context. You've got vast amounts of data, but no information. That's the issue. So those are the challenges that we need to try and fix. So what's our view, VMware's view, about how to simplify that and what Security 2.0 needs to look like? First of all, we need to stop thinking about security as being a wall that surrounds the whole network, and putting all your money into that and then expecting that to defend. You've got to think about security now as a distributed service, not one great big thing around the edge, but you've got to make every element within your infrastructure secure in and of itself, and use technologies such as zero trust to be able to provide the fundamental philosophy and engine behind securing all of that. So built in rather than bolted on, and distributed throughout the infrastructure. The too many silos thing, well, we have to link everything together using this philosophy of zero trust. Say there are transactions that are happening between all elements within your infrastructure all the time. So between users, between devices, between applications, between microservices. Zero trust says don't trust that any of those are valid or secure. You have to check and you have to validate every single one. And if you actually take that attitude, that simplifies your security model entirely, because essentially you don't trust anything and you validate everything. Finally, the context thing, we have to start thinking about looking at all of this in a much smarter way. So we have to have all this data, but we have to bring it all together and curate it in a way which means that we can actually get an understanding of what's happening throughout our infrastructure. But I mean throughout our infrastructure, not just around the edge, which is the old model. So we've said, delivering the vision. What is it that this new model needs to do? It needs to, first of all, have this security distributed across and between all assets, and you need to do that from the start. So if you're developing a new app, you need to build security into the app rather than rely on somebody else to bolt security on when it's implemented. And you do that, as I say, using the standardizing principle of doing that is you use the idea of zero trust. That's also important within the context of a multi-cloud environment as well, because that if everything is not trusted and therefore there is a validation mechanism, you can actually, that very easily layers on top of a multi-cloud environment. So when you're passing stuff, applications between environments, security essentially travels with the application rather than being fundamental to the cloud itself. Too many silos. How do you do that? Well, the answer is you identify within your infrastructure what the clear control points are. So they're things like devices, things like users, things like the network, and you concentrate your security into those individual elements within your network, and then you connect them together in terms of being able to communicate and curate all of this data. By doing that, you start to also, interestingly, have the side effect of actually starting to unify the teams that do that as well, because they all start to be interested in the information that comes from each of the individual elements within the control points. That becomes important as well. So it starts to build trust and build interworking between these different functional teams as well. And then the context element is, as I say, you start to bring everything together and link it all together in a way which means that curation starts to mean that all of your information starts to link together and gives you a much more accurate picture of what's going on in your network, in your infrastructure. And if you know that, you can tell when it starts to deviate from what you expect it to be. And that's essentially the way you would start to look at new models of security. Now that's sort of our philosophy, and that's what we've been doing now for the last 18 months, 2 years, 2.5 years, certainly since we acquired Carbon Black, but we've also started to unify the other security tools within our organization. But that's what we think. How does that map onto, in our experience, what our customers and what our prospects that we're talking to are saying? Well, there's 3 key areas that we see that our customers are see as being important and that are investing in. First of all, modernizing security within their organization, so the operations center. So this is some data that we commissioned in a survey with Gartner, but they're saying that of the respondents to that survey, over half now, nearly 60%, are actually increasing their investments in information security along the lines that we're talking about here. Secondly, it's absolutely about cloud. There's no question that all of this fits perfectly as a model into implementing multi-cloud, and specifically within multi-cloud, looking at how we develop applications to be secure from day zero, if you like, rather than actually adding security on to the infrastructure later. And then the final thing is, none of this makes any sense. There's no point in producing security just in a bubble within the cloud or within the data center if your end users can't access this stuff in a sensible and easy way. Then none of this makes sense. So we have to secure what's increasingly a quite challenging and distributed workforce. I mean, we all, to a greater or lesser extent over the last couple of years, have been working remotely, or at least I'm presuming that most of you have had at least an experience of working remotely over the last couple of years. And there's, pretty much a third of respondents are also massively increasing their investment in the back end to be able to take advantage of all this happening at the front end. The other interesting thing about this, and again, research and so on, is it's absolutely showing that security, and in fact, large chunks of modern IT, is a team sport. It absolutely relies increasingly now on people from cross-functional areas actually working together. That's the only way that many of this makes sense. So, I mean, who knew? Security is a people subject. Nobody would have said that 5 years ago. And fundamentally, our security strategy takes that into account. So, all of those functional teams around the edge, one way or another, use to a greater or lesser extent in full function VMware implementations. We have examples of tools and products which exist in all of those areas, and they all map onto the various parts of these control points. So workloads, cloud, network, access, which is users, and endpoints, which is devices. So if you want to start, as I say, from the endpoint, then Horizon obviously is one of the world's leading VDI products. Workspace ONE, as we've seen earlier, is about user environment management, and that has instrumentation and tools to provide this zero trust security in there from the endpoint device. And then equally, when you're talking about networking, we're talking about NSX. Those of you who know about NSX, it's a network virtualization tool which plays a significant role in security, but with technologies such as microsegmentation. SD-WAN is virtualizing the wide area network. So we made a strategic purchase a few years ago as an organization called VeloCloud, which allows us to do that. Last year, we announced sort of VeloCloud on steroids, which is SASE, which is adding and integrating security into the wide area network, software-defined wide area network. So all of these things implement the sort of technology functionality that we're talking about here. Tanzu is about environments to enable the development of modern apps and management of those modern apps via things like Kubernetes. Again, all of that slots in and is instrumented to be able to transparently use this sort of distributed security model. And then clearly, those of the longest term VMware customers will be happy users, hopefully, of vSphere and management of our private and public cloud offerings as well. So again, all instrumented to be able to provide this from an end-to-end basis. And then at the tip of the arrow, if you like, is the Carbon Black offering, which is our offering for a tool set essentially for the InfoSec community. So again, talking specifically their language. But fundamentally, the way all of this works is, as I say, it unifies and curates all the various information that comes in to actually make useful, enable the people who manage these various networks make useful decisions. So, and as I say, in most organizations, to a greater or lesser extent, they already have these tools there. So this modern Security 2.0, in many cases, doesn't even involve the customer actually having to buy anything new. They already have much of this functionality there. They might have to buy Carbon Black. There might be a couple of other things in here which, to get the full benefit, but fundamentally, a lot of this is already there in the existing product. So let's just dig a little bit more into Carbon Black. So Carbon Black is about providing security at a cloud level, at a workload level, and at an endpoint level. And it does it via essentially machine learning and behavioral analytics. And that's what makes Carbon Black very different to the traditional sort of virus signature, understanding what bad looks like. With this, you don't have to understand what bad looks like. You just have to know what good looks like, and to be able to tell if something gets infected by some sort of malware or there's a breach, typically it will make the steady state look different. And Carbon Black uses, as I say, machine learning and behavioral analytics to be able to tell that in a very, very sophisticated way. So the way to think about Carbon Black is it's effectively a sort of single sensor that's installed, and then there are a bunch of modules which you can add or turn on or off as per what your requirements are. And it fits into the three classic security operations models of identifying risk, preventing breaches, and detecting and response. And all of these modules are all available as part of the standard product, and it's up to you which of them you want to use within your own organization. What's interesting as well is that Carbon Black as a product portfolio doesn't just use the standard, within physical environments of various types, within the key cloud providers. It also operates across the cloud. It will operate on-premise. It will operate in the cloud. It will also work with virtual machines or with containers, so it can pretty much cover a typical modern application-oriented environment. So fundamentally, Carbon Black is about providing all of this instrumentation, and it does so using what's effectively a single sensor, which is fairly unique. It's, as far as this is concerned, it's essentially an agentless security portfolio. Now, we talked earlier, I mean, in one sense, this slide you might say, well, you're talking against yourself, Garry, here. Because in one sense, you said one of the problems is the proliferation of of products? Well, the answer is we also know that nobody is going to say, we've got our old model yesterday and we're just going to move, we're going to forklift in, take the old stuff out and install carbon black. So the reality is we know that security 2.0 has to be about evolution, not revolution. So carbon black will work transparently with all of your existing security investments, well, provided these are some of the point solutions you have. So there's currently over 125 integrations with various different security tools, and you can add value to all of them and use carbon black to integrate them together as you manage all of these other solutions out of your security infrastructure. So diving a bit deeper, in fact going beyond where carbon black is, this is about now some of the back-end stuff. So access, validating users, and actually how do you put security into the network? Well, a typical data center environment, obviously you'll have your typical application servers, you'll have often your security appliances and analytical engines and so on at the end. Now the problem with this model of security, with the old model of security, it's not really built to deal with this, because if you think about it, basically you'd have to take an application from a particular server, would have to basically send its transactions into the firewall or into the load balancer or whatever, then hairpin back to wherever the next one is. Now in a distributed environment where everything is by definition distributed, that means this is a very, very inefficient way of doing security or doing load balancing or doing any of those sorts of things. So we have to think about a different way of doing it. So one way of doing it is to use the concept that VMware is well known for, virtualization. So why can't we break up the functions of these individual appliances, virtualize them, split them into 10,000 little ones and apply those directly to the servers themselves, run them as software. So as I say, we can take the firewall, we can break into 10,000 pieces and apply those as software to the individual workloads. And we can do the same thing for the IDS appliance, we can do the same thing for load balancer, we can do the same thing for the analytical engines. Now what that fundamentally means is, apart from you don't have to have these cumbersome, inefficient hardware appliances any longer, it means that all of this security stuff is now associated with the applications that it applies to. So if you think about it, this is what we talked about earlier. This is about breaking everything up, applying it locally, much more efficient. But that's not the only place that we can maybe apply this. So we can also apply it to the network. So a typical requirement would be, let's say you happen to be somebody working in the Sao Paulo branch of Acme Industries, somewhere in South America there, and they need to send something to, I don't know, to Sydney. Now the way that would work in a traditional environment, using that model that we said earlier, is that you would log on in Sao Paulo, whatever your transaction would be sent up to the DMZ somewhere, let's say in this case in America, because that's where your appliances are, and then be sent out. And then the response would come back the reverse direction. And again, this hairpinning is extremely inefficient. So why don't we apply the same virtualization principle to this? So instead of having a single DMZ somewhere, why don't we break that up into 10,000 pieces and apply those little pieces into local points of presence instead? So now if you want to enter your network from Sao Paulo, you can actually log on to a local point of presence, which improves your performance. It makes your security policy stuff much more granular. Generally a great solution for corporate comms. But interestingly, not just corporate comms. Those of us who have been working at home over the last 2.5 years will realize each of these, you can actually abstract it down to the home as well. So the reality is, why don't you have what's essentially a little point of presence, a little access point within the home? And in fact, this is what we've done. Over the last 2.5 years, we've actually had these products where we can, I mean, who knew? VMware is actually a hardware vendor as well. So we produce these little hardware boxes, ship them out to customers who happen to be working from home, And that deals, it effectively turns a consumer broadband connection into a managed enterprise connection by doing that. And we've shown that can reduce network performance issues by up to 90%. So you can actually work from home and still have your kids doing home schooling and watching Netflix and everything at the same time. So basically, just to summarize, so the recap is that we think this Security 2.0 strategy, where it's about re-engineering things to actually have a different vision for security. It's not about surrounding everything, bolting security on. It's about building security in, and then applying that across various use cases in the business. And we believe that that's mirrored by what the data is telling us that customers want and are doing. We've also said that the new security is about delivering it as a built-in distributed service. It involves a new fundamental philosophy for how we do security, which is zero trust. Zero trust is the way we fix the problem of everything being distributed, and that we have to take all of the various information that comes in from all the different functions within the organization, curate it intelligently, and provide this context that takes all of this data and makes it into useful, actionable information to keep your networks more secure. Slightly over, but not too bad. So any questions, or do you want to just grab me during the after the film or during the meal? All right, thank you very much.
Thanks. Awesome. Thank you.